I'm just actually connected to NASA too. So the Holy Land Democracy Project brings teachers to Israel to experience Israel firsthand, and then we take that back and share that with our students. Most of the teachers are social studies or religion teachers or English, and I'm the first science teacher. So I had to figure out a way, how am I going to bring Israel back into a science class? And so I contacted, through NASA, someone who contacted me through someone else, and they ended up bringing me to you. So I'm touring, and it's been a lovely experience to be here in Israel. I've learned so much, and you are wonderful, and I'm thankful to be here. So I get to wear two hats, and tonight I'm now doing the NASA thing. So I'm a teacher, and I teach 7th grade students math and science. I specialize working with gifted education, and I've been doing that for a while. So the question here for you is, what is SOFIA? And how many of you are already familiar with SOFIA, the mission? Okay, just a few. Okay, good. So SOFIA is actually a 747 that has been everything's been taken out, and then it's been fitted with something that looks like a garage door and a really large telescope that uses infrared light. So SOFIA is an acronym, and it's the S stands for stratospheric, and in a minute I'll explain why. But actually, I can tell you why. So SOFIA goes up and has to fly up above all of the water vapor in our atmosphere, because the water vapor would get in the way of the infrared light. So the S stands for stratospheric, and the O stands for observatory. So this is a flying observatory. It goes up at 6:30 or so at night, and then it flies all night long. So you have to stay up all night long. You have to also bring your own food. Got to bring your own coffee. Got to bring your own Diet Coke. They maybe have water. It flies all night, and then it comes back down in the morning. So I have a couple satellite type things that are up in space, and so you already probably are familiar with these that use different kinds of light. And so we had Spitzer there. We have other things that use infrared light. So I guess my question to you is, why would NASA spend so much money to create an aircraft and fit it with an infrared telescope when we actually have things up in space? So why would NASA do that? Yes. It's cheaper. Okay, possibly we've spent a lot of money on this one, but that's a good thought. Ben's like, I know. Do you want to share, Ben? Tell me. Explain more. Okay, good. You're definitely onto that. So we can go where we want to go to look at what we want to look at, and then it can be modified. Excellent. Do you have something else to add to that? Good. Okay, good. Very good. Did you have another thought? You were helping him. Good, good. And the other thing, too, is things like this use different chemicals, cryogenics, and they use it up. So after you use that up, then you can't use it anymore. And so SOFIA comes down, and it can be updated, and instruments can be changed out. And so it's the only observatory right now, flying observatory in the world. It's a one of a kind. 4 just simply is a preposition, and the F stands for 4. I'm using this on my iPhone. And the I stands for infrared. And so are you familiar with this? Should I go into infrared at all? Yeah? So there are different kinds of light, and you already know this. This is the light that's visible light that we see with our eyes, right? And then there are different kinds of light. And this is the spectrum that SOFIA uses. And the infrared is able to kind of peer beyond the stardust. So it uses that sort. This gives you an idea if you're not familiar with infrared. And you can see this right here is looking at an individual through an infrared camera. And you can see here he has a black plastic. And you can't see his hands. But using, this is regular light. And here's infrared. And you can see that infrared can go through plastic. It can't go through glass. So infrared can go through some things that regular light can't go through. And that gives you an idea of why SOFIA has to fly so high to get up above all the moisture. The moisture would do the same thing that this does. And so we fly at the very top of the stratosphere when we fly. And you can see here, infrared is also the light that's heat. And so you can see the hotter parts of the cat there. The A stands for astronomy, and you guys all know all about this already, and so I don't even need to go into this, all the different kinds of astronomy. I don't need to talk about that to you guys, because you guys are all into this, right? All right, so that is what SOFIA stands for. So to kind of encapsulate this, this is what SOFIA looks like. And, you know, opening a big hole in an airplane is problematic when you think of it. And so they had to do quite a bit of testing in a wind tunnel where they had to make a model and make sure they worked. Here's where the telescope is. And they have to be very careful if they open up the door and there's, we're going through any kind of, like if a cloud is there, they have to quickly shut it. It's hardly ever open during the day. If it's open, it's when it's inside the hangar. It's based in, yes? No. Oh, this was a test flight. This was in the very beginning when they were first testing it, I think. Are you talking about that? Is that what he's asking? It's not usually open this low. They don't open up the door until we're really high and they're about ready to start doing the science time. Then up comes the door. Yes. Did that make sense? Okay, good. So it's based in Dryden, which happens to be 10 minutes from where we live. So when we were first applied for the program, they opened it up to teachers, and they were looking for teachers in specific areas, and I have a video to show you that in a minute. And I was the cheap date. So there were 6 teachers that were chosen from around the United States, and I live right there. In fact, I didn't introduce you to my husband. Oh, so bad. This is my husband, Mark. I'm so sorry. I'm so sorry. Oh, it's so bad. Oh, that's so bad. Okay, so we can actually see SOFIA take off from our back window. And we're very close. So I was the cheap date. They had to bring everyone else out, but I live right there. So the very first science started in 2010. And this is our goal, to have about 120 8-hour flights per year. And the good thing about SOFIA is that it has this long lifespan. So as I go to talk to students, I often tell them, you could actually go through college and you could work on SOFIA because it's going to be around for a while. In fact, I was saying, I was saying to Odette that, you know, the 747 that carried the space shuttle, did you see all the pictures of it touring all over before? Well, it came back down and landed right where SOFIA lives. And it's parked outside. There's no space for it inside the hangar. It's parked out there. You can see it. It's got the little things. It's the exact aircraft as SOFIA. They're going to cannibalize it, take it apart, and put the parts in the hangar and put some of it into the Smithsonian. SOFIA is a German-US joint project. Germany put in 20% of the funds, and America put in 80%. So they get 20% of the time. They worked on the telescope. And so there are Germans right there, always there, wherever it is, working on it with us. All right. Any questions so far? Good? Okay. I think the answer, oh no, from that one side, they position the aircraft to whatever they're looking at. Is that the right answer? Okay. No, right, no, the position of the aircraft is what it is. So here's a cutaway, and if you go on the SOFIA website through NASA, you can actually do a virtual tour. But this is what it looks like. Everything's been taken out. There's some first-class seats right up here, just a few of them. And then these are all science consoles. So the principal scientist is here. The operators, the telescope operators are here. Different engineers. And the educators are right here. So there's always two educators that their goal is to have an educator experience this, go back, share it with the community, share it with the classroom. And so when I first flew, SOFIA wasn't ready for educators. And at the very last minute, the deputy director said, let's get some educators on this. So it was prior to when they were ready, there was no console for us. So we just stood around and watched and talked, and it was really great. So this is what'd you say? Yes, for 12 hours. I went up and hung up with the pilots, and then I interviewed everyone. So, in fact, before I went the first time, I had my students do research. I developed a web quest for them. I had them do research, and then I had them, as the final part of it, ask, what do you want to ask the scientists? What do you want to know that we still don't know? So when I went on the first flight, I went armed with all these questions that my kids had. So it gave me something to do. So I would go around and because everyone is standing around, you fly, and then the door opens, and you can't really see anything. I'll show you a picture of it. The console is just like a little fuzzy dot. You can't really see anything. So I spent a lot of time, since I talk a lot, I spent a lot of time talking to all the different engineers and scientists, and I interviewed them on film. Yes, and I'll show it to you. So this is in front of the bulwark. So that's the telescope's on the other side. So it's a pressurized cabin. People often say, oh, were you in zero gravity? Like, no, it's not that cool. It's just like a pressurized airplane. But this is really cool. This is the telescope. You can touch it with your finger and it moves. It's just so smooth. And during the flight, this looks like it's moving, but it's not. The telescope is stationary and the plane is moving. It's really cool. And I have a video of it, and I'll show it to you. So there I am at the end of a flight. This is another educator from the Midwest. And they always send us with like a handler. What would they be called? This is someone from NASA that works with educators. So, this is when NBC came to my classroom. That's my school.
Say she's excited. Doesn't even come close. I'm excited for flight and for the second year. And on the 31st, NASA hasn't said what we do, where, or what type of research that we do. They will work alongside top level scientists on board the 747 named SOFIA, the Stratospheric Observatory, Fredette is from. Fredette is anxious to share his field experience on Earth found students. This fits into our second grade school bio, and then we have how light year has with biology. So we go into the electromagnetic spectrum and correct. So that's kind of how it fits in my classroom. And the students are thrilled. Their teacher made the cut. That's what he loves. Like not many people get to see the teacher student. There's not many teachers that care as much as she does. So she's probably one of the teachers.
I paid him to say that.
Fredette was married with 4 sons, discussed the dangers with her husband. I think my brain is probably written out as well as the present. It's so much. You're not going to Fredette believes just being selected is a lesson for science lovers of all ages. If there's anything I'm thinking that kids might grab from this is there are just opportunities out there. Unlike the other 5 airborne ambassadors, Kathleen Fredette won't travel far to make her flight. The modified 747 is based at NASA's Dryden Aircraft Operations Center in Palmdale, California, and the school year runs until June 25th. Plenty of time for Fredette to share SOFIA's science with her students. I'm Beverly White. Chuck it out. Back to you.
What was that? Was it okay? Okay. So after the selection came out and was announced, everything okay? Okay. Hello. Welcome. Glad you're here. So after the selection came out, cameras started, TV stations and radio stations started calling, and I said, no, I don't want to talk to anyone. And then they made it to us. So the next video that I have for you is actually Dr. Backman. Let me make sure this is who I'm showing you next. I think it is. Let's see. Yes. Can I pause this? These are my student questions.
Hi, this is Natalie, and I was wondering how the teachers were selected to have this opportunity because we love NASA's decision.
Can I pause this, or will it mess everything up?
So, the choice of teachers,
Yeah.
3 groups of teachers who were already related to SOFIA who were trained to understand.
Okay, this is Dr. Backman. You're Dr. Backman. Dr. Backman is the head. And he's up in, oddly enough, the science portion, the education portion happens on the other side of California in the northern part. And so that's where he's from. We were down one day and I asked him to explain to me, how did you choose the educators? So he explains that first, and then the next thing that he explained is how do they choose what science they're gonna do? So how did they select the astronomers?
For the past 2 years, I've been expecting to be one of the minds from SOFIA. We were also did decide to also pick teachers from 3 geographical areas, specifically one near SOFIA facility. So the Palmdale area, the San Francisco Bay area, and Washington, D.C. area. So we tried to mix these 2 groups. Teachers from was already sort of familiar groups that were kind of in-house, and
Mine's over there.
that we didn't know from the geographical areas. So that's how we put the first 6 teachers chosen. With 3 each of those geographical areas and 1 each from the in-house groups.
So when you looked at the application, what kind of tool or what did you use to weigh the application?
We just had we assembled a team of educators who judged them, ranked them, read them all, ranked them, and then we had it got together and we averaged the scores from the 4 evaluators and ranked the teachers essentially from these 6 groups, and then called up the first ranked teacher from each of the 6 categories. So again, I could add, this is very much like the process that selects astronomers for observing SOFIA. Send in their proposals, new panel of their peers judges the proposals, ranks them, and then they assign telescope times, SOFIA flights, starting from the top and down until they run out of available time on SOFIA. In the case of SOFIA, it's about 3 to 1 between the number of astronomers flying and the number who can get on board. And that's normal for a big observatory, 3 or 4 to 1.
So that's Dr. Backman. He's kind of like my boss. And there's what SOFIA looks inside the hangar. So that gives you an idea of how big it is. This hangar, this is a little tidbit. Before SOFIA lived here, this was the place where, did you see Pirates of the Caribbean? Yeah? That was filmed in here. And they actually had turned that into like a really, really big water, and they could actually have the model of it, and they did a bunch there. So we live out in the desert in Palmdale, and then Edwards Air Force Base is a little bit further. They do a lot of filming out there. So anything like when you look at, what is that? Oh, never mind. A lot of stuff is out there. So that's what it looks like inside. And here's the cockpit when I flew the first time. You can see it's really, really, really old school. The 1970s is when it was built. And so I got to actually be in the cockpit and land with them. The sun was coming up. It was really beautiful. My husband was really jealous. He's learning to be a pilot, and so that was very fun for me. So this is what the technology looked like. I mean, they had like the toggle switches and everything, very old school. And then last summer, SOFIA wasn't flying. They were completely doing a facelift. And I was fortunate enough, since I lived there, see, everyone else was like, got to fly in. I lived there, but here's the cool thing. I got to invite about 50 educators from around our valley to come to a training, and we did some hands-on infrared stuff, and then they got to see SOFIA. And, oh, these are my boys. This is the deputy director of SOFIA, and my boys, these are 2 of our sons. We have 4. They got to come and help on that day, and that was really fun for us, too. This is what the plane looked like last summer during that. And they said, oh, you can't take your teachers. You cannot take your teachers into SOFIA. And then when we were there, I kind of did that beggy thing. Can I please take the teachers? And so they actually let us walk around, and the whole plane looked like this. And it's amazing that they got it back together. All right. What do I have next for you? So here's what SOFIA looks like in the morning going out. And they actually have on every flight a videographer. This particular videographer, he lives near where we live, and I had his niece in my class. And so a lot of the people that actually work on SOFIA, I was like, oh, I know them because I was the teacher of your kid. He came and spoke at my school, too. And so let me say this, that not all my kids want to be scientists. And so one of the things I tried to do was to talk to all the different kinds of people that are involved in this great thing, and then to bring that back. Oh, you're interested in videography or cinematography? Great, look at this. You could work for NASA and do this. So a lot of what I talk to the students about is how do you find the passion within you and then follow that? And how did you get to do this is the question I ask a lot. This is, on every flight, there's someone called a principal scientist. So there's a device connected to the telescope that is going to read the infrared. Different institutions say, oh, we'd like to do this, and they create that, they bid for it. And this is Terry Herder out of Cornell University, and he was the principal scientist the first time that I flew. And when we got on board, they said to the educators and an astronomer, okay, 2 of you get to be in the cockpit when it takes off, and 2 of you get to be in the cockpit when it lands. Well, of course I wanted to be there for the takeoff, right? But I was like, oh no, you go ahead. Well, I won because I was sitting next to Terry Herder for the takeoff, and I interviewed him. And so it's a little bit choppy because it's actually pretty loud, and I'm going to show you how loud it is. But what I'm going to show you next is Terry Herder talking to my students about his high-level tech camera device that's connected. Whoops, I'm sorry. Went the wrong way.
Hi, my name is Melissa, and I have a question. I was wondering if you could tell me a little bit more about the SOFIA. Like, what other types of instruments that were used besides the infrared telescope?
Technology here beyond the telescope. Imagine cutting a big hole inside the airplane and putting something in it and making it operate. And the other thing that is a key part of the technology is making it stable, so it looks the same part of the sky which keeps it perfectly go around. It's hard to actually imagine how accurate SOFIA has to be. But the way it can do that, the plane runs all around. What really happens, imagine yourself putting on an air hockey table with a hockey puck. And normally you move the hockey puck around, but if you let the hockey puck alone and you move the table around, the hockey puck will stay in the same place. The telescope sits on basically a big bearing. It's basically a cushion of oil. It could be a cushion of air, but it's a cushion of oil. And the plane turns around it, and the telescope stays stable. That's a key technology that makes SOFIA actually work.
What keeps the oil from not...
How does the oil work?
Yeah, how does that work, and how does it not get into the different parts of the telescope?
Well, it's a good point. It has to be very high pressure, so it lifts basically the telescope up a little bit. And there are little catches around the side, so it prevents the oil from leaking. And also, really key for it, they actually have to control the temperature of the telescope bearing and too hot or too cold.
And so how do you control the temperature?
Well, it's an issue of the heaters, keeping it at the right temperature and altitude, basically. So it also is affected by the cabin temperature. So that's sort of the answer in the other piece of technology was the part we provide, which is the science.
When you say we, what do you mean?
We're a science team that was responsible for constructing one of the, like, called cameras, especially little cameras that goes up. So we have your cameras in your cell phone. We take pictures. So our pictures occur in what's called the infrared part of the spectrum. It's called infrared because it's beyond red. So a lot of people talk about it being heat. You go near a fire, you put up your hand, you feel the heat. Well, it actually is infrared radiation coming from the fire. And that's what we look at with our cameras. We have a specially built camera that's basically unique in the world.
What part did you play in developing that camera?
Well, I was called the principal investigator, so I'm responsible for basically the whole thing. So the design, fabrication, implementation, and running. I have a team which consists of engineers, mechanical engineers, electrical engineers, software engineers, some scientists on the group, and graduate students on the group. We also, as part of that, the technology program comes from industry. The detector, we call it, that allows you to take the picture. Actually, the detector itself, what they can touch in here is a special department we have to go to industry yet. And so basically it's built much like the device here, there's a big difference. One of the things you have to do, remember, I call it heat radiation, the infrared. Well, the instrument we have is actually cooled down to very low temperatures, about minus 169 degrees centigrade, very cold. And the reason for that is, there are two reasons. We don't want the instrument to see itself, okay, because otherwise it would be radiation. And the actual detector, we call it, detects the light, or the photons. We don't want it to see itself. So you need to cool it down to prevent it from seeing itself.
How do you cool it down?
Well, it uses liquid nitrogen, liquid helium. Liquid nitrogen is basically 77 degrees Kelvin, and liquid helium operates at 4 degrees Kelvin. As I said, that's roughly minus 269 degrees centigrade. Very cold.
He was so Yes. What I really liked about, well, all of the people that I met is I tease out their, like, they talk and forget that most people don't know what they know. And so they've been so patient about letting me ask and explain things so that my students can know. What I want to show you is just a couple of the people that I met on the flight. This is Jim Mills. He was an electronic engineer and they had to put over 4,000 sensors along the whole body. And even so, eventually all of this is covered, but on that first flight, it was all open. Because they have to be careful that there's no compromise on the body. And so he was the one who did all that, and I was able to stand and talk with him for quite some time. And this used to be, you know, in old school, well, when you fly in America now, we don't get food. Do you know, like when we fly here, we got food? This is where they used to keep the food in the 747. Well, now this was the electronic panel, and so they've just adapted that and thrown it in there. This is what it sounds like. It's actually this loud on there, and you have to yell like this, but let's turn it down, way down. It's really that loud on there. And so the first flight, they didn't have an educator's council for us, and they didn't even have headphones for all of us. So if we were talking, we had to yell. And you can see people are just standing around. So that's Jim, the gentleman that I just showed you. And there's Terry up there where the scientists are. They had called him up. They always have, that's a little bear. They always have a little mascot from the school that it's connected to. It's an airplane. Yeah. See how everything is open? Yeah, but even so, the second flight was just as loud. What were you going to say? Yeah. Yeah. This is one of the astronomers that, and everyone's kind of just up and around, kind of waiting for the next thing to happen, talking. And that's what it looks like inside. I think did I pan over yet? Did you see it? Yeah, okay. I'm going to go on. No, not a thing. No, because you're on the other, see this part right here? This is like a bulwark. So you can't even tell. Like they have to kind of let us know, okay, the door is open, because we don't know. There's nothing. Nothing, which is amazing, right? Since it's such a big door, right? Nothing. No, it can't, right? And then when they first started testing it, they would go up and they would open it a little bit and close it. And they would have a jet flying right next to it taking video. And then they'd go a little further and open a little bit further. A lot of, from the, no. Yeah, my husband knows about this. Go ahead, say that to them.
Very slight bump, rising right before the opening of the door, so that the deflection of the air goes around it, goes back on the tail side, and so there's a bit of a vacuum right there.
Thank you. I threw this in because I wanted my students to meet this person. This person only had a 2-year certificate as a flight mechanic. So he got out of high school and he went to flight mechanic school for 2 years, and then he worked someplace, and then he got hired by SOFIA. He actually graduated from a high school very close to us, right in our valley. And so a lot of the students that I work with, not all of our kids can or want to go to a 4-year university or a 4-year college. Of course, we want to encourage them to, but I think it's important to give them other options, that maybe you want to go to a trade school, and that's a good option too. And here's a guy who did. And then that's, I talked to you about the videographer. They followed us around like crazy taking pictures. This is, again, I really love that Beth and her husband work on the telescope. And so there's different crews that come on, but she happened to be the telescope operator on that, at that time. There's Terry, and there's the back of the telescope like I was talking to you about. The forecast is right here. So this is the thing that he created, and this is the one that when they're going to use different kinds of science, they take this off and put the next one on. Take it off and put the next one on. And that's what the screen looks like that the astronomers are looking at. So to me, it didn't say a whole lot, but and it really, there was like a moment of excitement on our flight, but really it was very quiet. It is until they go back and they spend a lot of time looking at it, and then they produce a paper. There's a flight director, and she looks like she could be someone's grandma, you know, and she's the one who actually coordinated everything. You couldn't do anything without her knowing. And that's what her screen looks like. All right, what do I have for you next? Okay, I have this for you because we did have to go through about 45 to an hour-long, really boring training where they told you every bad thing that could possibly happen to you on this aircraft. And then I had to sign a little piece of paper that said, if I die, I won't come after you. And so we did have to wear this everywhere because there's only about you know, less than 10 seconds to get this on, you know, before that you would pass out. Yeah, yeah. So we had to wear that everywhere. 41 to 44. That, yeah. So here's the cool thing. I told you this is that these are some of my students. There's my husband. This was the director, and this was the assistant deputy director. He is now the director. His name is Eddie Zavallo, and he has such a heart for education. Really, really wants. And I'm going to show you if you can stand me talking. You have to tell me if you want me to stop because I will. But I have a short video clip of Eddie came right to my classroom. So even though he's this high-ranking NASA person, he's like, no, I want to come talk to your kids. And so he did. So I got to bring my kids to right over to SOFIA for a media day, which was really cool. And here was someone that I interviewed and brought back. Whoops. Turn it up more.
Making our image quality even better than it already is. And what I mean by image quality is if you take a picture of a star, what you're going to see is basically a round circle. But if the camera is slightly out of focus or even really bad out of focus, that sort of ball of light will spread out. Astronomers want a picture of a star to be as concentrated as possible, like a pinpoint of light that shows up on the detector rather than a big fuzzy ball. Right now, SOFIA is doing a really good job in its image quality. In fact, the size of that stellar ball is smaller than what we thought it was going to be at this phase of our program. But we don't want to just stop with what we've got right now. So we have an actual plan to make that image even better here. And one of the things that we're going to be doing to try to make that image size even smaller and tighter and even better focused is to use some devices that are installed on the telescope underneath the primary mirror and possibly even on the structure that holds the secondary mirror to try to dampen out vibrations. Now, one thing you want to remember about SOFIA, it is a telescope that's flying in the back of an airplane. And the airplane, even though it provides a really smooth ride, it does encounter turbulence every now and then. And there's a little bit of vibrational motion, as many of you who have flown on the plane realize. Now, the way that the telescope is positioned in the plane, it's very well isolated from all of these jitters and vibrations. But there are a few vibrations that manage to get to the telescope. So you don't want vibrations. You don't want the telescope doing this because that smears the image. And so one of the things that these devices are called active mass dampers are going to be able to do is to help minimize those vibrations. So the telescope is doing this right now, and then over time, those dampers will just dampen out that motion. Very much like when you're in a car, the screens that are under the seats and the shock absorbers that are in your car help dampen out the vibrations of sitting in the seat. So when you go over a bump, you don't even feel it. And that's exactly what's going to happen with the telescope. So that's one major improvement that we're going to be making to the telescope in the near term. Like, you know, we're going to be doing some test flights in October that test out this active gas damper.
And they already have done that. So that was actually kind of old news. So they've already done that. How are you doing? Are you okay? Can we cut just a little bit more? Okay. So here is my classroom again, and Eddie Zavala. I just told you about him. He's the deputy director right now. And when I told him when I was coming to Israel, he was one of the people that I emailed and made sure that I could get to the right person so that I could share this. He came to my classroom and just spoke with my kids, did a lot of hands-on, really cool hands-on stuff. And here he is talking to one of my kids.
That is bigger than a quarter, and you're a lot closer to 5 minutes. Okay, so the way I do it, I want a nice clear image. Bring up. Okay, but you're too close. Come on. Come back here.
He's modeling how the telescope is able to get a really clear image. Yeah, he's showing how SOFIA gets it really, how we have to get it real, everything really, yes, okay, there you go. Yeah, and not like this. Yes, yes. He was great, and that's one of the things I've really enjoyed about working with them is how open they are to really working with kids. Yeah, there's so many. I have to show you. Yes. So last year they called me in the fall and said, Discovery Channel. Do you have Discovery Channel here? Yeah, of course. Sorry. Discovery Channel was doing a series on Great Planes. They did one on Great Boats, and SOFIA was chosen to be one of their Great Planes. So they wanted some educators. Would you fly again? Oh, right, I'll fly again. So here I am with the Discovery Channel crew, and this is one of the other educators, and there we are inside the hangar. I think it looks like a whale. It's so shiny, and they're up there buffing it out. It looks so pretty. And one of the things that we did this time is now they had the educators console. So I worked with Dr. Backman and the other educator, and we looked at this screen and said, uh-oh, we don't know what this means. And as educators, we made a little map of it so that as the new teachers come on, they'll know what they're looking at. So we spent that next flight, I spent with Dr. Backman, we came up with what does an educator need to bring, et cetera, et cetera, et cetera, and we did that. And that's the new educator console right there. And that was my second flight. And now I'd be happy to take any questions. Yes, any? Let me say this. I'm going to say something. If you are interested in some of the most recent things that SOFIA has, like, what are the new discoveries? I'm going to defer you to the site. You want to see pictures. This, yeah, see. And that's what I was just saying, is that the things that are coming out that they've published, I would defer you to the website, and then you can look at all of this astronomical data and look at that in detail. Much better than me explaining it to you. Sorry. Oh, okay, Ben can get up and do the next part. Okay, yes, feel free. No, I'm good. Feel free. Are you talking about my videos?
No, but you said you're flying through tonight, and the night is not set. No. So we asked why, how come there's flashlight?
Our telescope why is there light there if you're flying at night?
Oh, are you talking about here? That's because we just took off. Inside the plane, the telescope is behind the bulwark, and you open the door, and there's no light back there. But on our side, that's a good question. On our side, there is, but where the telescope is, there's none. Good question. Very good question.
We just show the Orion.
Feel free. That's right.
Do you know how much a plane costs? What's the cost of a flight? No personnel, just the plane?
No. Sorry. No, I'm not even going to ballpark it. All of that information, all the specs and that, yes, absolutely, right on the SOFIA website. Go. Yeah? Yes, and I brought some of those for you. You can explain that. Yes, you can talk about that. You're talking about this? Yeah? Yeah, good. Yeah. Ah, so here's some of the early stuff. You want to look in? Sorry, it got wet when I was flying over here. Yeah, please do. No, please. I told you you're the astronomer.
אז יש פה את קבוצת אוריון, למי שלא זיהה, באור נראה בצד שמאל ובאור אינפראדום בצד ימין. סליחה? זה מקליט, זה אמור להקליט. ואפשר לראות את ההבדלים של מה רואים כשאנחנו מסתכלים בעיניים שלנו משמאל ובטלסקופ כמו סופיה מימין. כל האזורים האלה שאתם רואים הבהירים שמאפשרים לנו למעשה לקבל את התמונה המלאה על היקום לידינו. שזה די לידינו, מדובר לא על גלקסיות רחוקות, אלא מדובר על משהו כמו 1,000, 2,000 שנות אור ככה בגדול. בן, אתה אומר שיש כאן עוד תמונה? תעביר לנו. אני מקווה שאני אוכל להסביר אותה. Ben is not making research, Ben is just wanting to know. That's the good thing about Ben. Lots of serendipitous learning. טוב. Anyone not familiar with this object? No, you go Jupiter. פה רואים את צדק מצד שמאל באור רגיל, פה רואים את צדק באור נראה, סליחה, פה רואים אותו באינפרה אדום. סליחה, איפה הרצועה? שאלה מעולה. חגורת עננים אחת חסרה, היא נעלמה והופיעה מחדש. אחרי כמה חודשים? אחרי שנה, ולא יודעים עדיין למה, נכון? לא יודעים למה, יש מחזוריות? סבבה. אז אם תריץ תמונות, יש פוסטר אחד נורא מפורסם של סופיה, אם תתחבר פה לווי-פיי אפשר יהיה להרים אותו, להראות אותו, שפשוט מראה מה רואה סופיה ומה רואים אנחנו. ועוד הפעם, תזכרו בבקשה שכשאנחנו מסתכלים על היקום, אנחנו מוגבלים מאוד בכל הספקטרום האלקטרומגנטי, כל מה שאנחנו רואים זה החתיכה הקטנה הזו. כל פעם שאני מרים טלסקופ חדש לחלל או לאוויר, או שאני בונה טלסקופ חדש, אני פותח עוד חלון ליקום, ואני לא יודע מה אני אראה בחלון הזה. יכול להיות שנגלה שם דברים שיהפכו את הפיזיקה שלנו all together, שזה יהיה נהדר. שפיצר זל, כן. ועוד הפעם, פשוט מקבלים תמונה אחרת של אותו אובייקט. תחשבו על בן אדם שאתם מסתכלים עליו ככה וברנטגן. תראו דברים אחרים. כן, רק שזה באינפרדום ולא ברנטגן, אבל זה באורכי גל אחרים. טוב, נראה לי רצינו, נשחרר את האנשים. מי שירצה מוזמן להישאר